show me how Jupyter would be the new Excel. What would it feel like to use Jupyter for these everyday number crunching tasks? So that's what we're going to do today. I want to just do a minimum of explanation. The whole web is full of explanations of data science and Jupyter, so we'll do that for 1 second, but then just get as soon as possible into me using Jupyter, you using Jupyter on my machine and doing things that are sort of ordinary number crunching, like your fantasy football list or your dinner party recipes or real estate prices. So I've got some examples I think are going to work here. I'm thinking of these as kind of things we all do with spreadsheets, and then we'll talk a little bit about what else you can do with Jupyter, and then get some local real estate data that I have and sort of proceed from there. So I'll say as little as possible about, I don't want to explain things, I want to sort of do things. So Jupyter with a y.org is the home of Jupyter, and there's more than you could possibly ever want there about what Jupyter is made out of and what people are doing with it, extensions to it, how to become involved. And I just want to sort of say it this way. That's a picture of a notebook there, by the way. And remember, you use Excel, I use Excel. This is like, here's a tool that we might use in place of Excel with some advantages. Python, as you probably know, is a programming language. By some estimates, it's the world's most popular programming language, and it's famously very, very easy to use, to get involved with. And that's one of the reasons I favor it. I sort of have Python. At any point, I've got Python running on my machine, and it's a little friend, I'm talking to it. One of the things about Python, it's known to be especially interactive. So typically with programming, you write a bunch of code, say in Java, and you hand it to Java, you make an application, and it runs. And Python has engineered itself so that you can just you can have little conversations with Python. You can literally say 2 plus 3, and it says 5. Or you have a little task, get all the files in that folder and send them over to Dropbox. So I always have Python open. I'm always sort of using it. It's interactive. It's famously interactive. Some geniuses invented this even more interactive version called IPython. And IPython, all of these are the basis for Jupyter Notebooks, but IPython is like not only interactive in the way I described, but you're doing some coding and it says, here's all the methods you can use right now. Here's what that variable you defined is. Here's how to back up a couple of steps, sort of making it look better and work better. It's extremely interactive. Those best features of Python all get put into the web browser, which I'll show you, of course, and that's Jupyter Notebooks. So the most important thing to know about Jupyter Notebooks are that they are containers, and they are timely containers. Like the whole world is going bananas for data science, and the whole world is going bananas to have reports written about analytics, like what was our web traffic at Castle Branch. Python notebooks, because they're a container, are just a very, very good container of the best features of Python as code, and then text. You can write text, these beautiful reports. You can put in code. It's not a copy of code, it's running code. And with that code, you can pull in data from spreadsheets or from lots of other sources, and then you can visualize the data. So I'm going to show you all that. Actually, so Amanda helped me put a message into the Slack channel, and I just sort of said, if you wanted to try Python and Jupyter rather, and I'll just say this about all the things I'm going to mention, especially Jupyter Notebooks, are free, and they are open source, and they're all famously easy to start using and non-invasive. So if you put these things on your computer just to kind of noodle around with them, which I do all the time, I use Jupyter Notebooks like to take meeting minutes. Go ahead and do it. Just go get this thing. I recommended that in order to install Jupyter, you grab something called Anaconda, which is this collection of a lot of data science tools. I'm not sure if you've done that or if you want to pursue this. There's lots of ways to get Jupyter, but this is Anaconda. All I've done is install it and then run it. And it presents this interface and it sort of says, what do you want to do, boss? The world's best data science tools are in here. They're all sort of fun and easy to get involved with, but you notice that it has Jupyter Notebook right there. So in the most basic way, if I just launch Jupyter Notebook, it's going to start itself up. It does a little squirrely thing right there, but then it's just going to launch a web browser. So we could start by looking at I want to get into like creating a notebook, but I'm running Jupyter, and Jupyter doesn't know yet which notebook I want to run. So it just opens up on, this is my, my home directory, documents, pictures, and so forth. And I keep a lot of stuff like temporary stuff in working. So this is really just like the Finder, Windows Explorer. I want to show us stuff in statistics. So I've started Jupyter. It's running on my machine. And now I've got some notebooks. You can notice you can select and delete and run around, that sort of stuff. But these things with I, P, Y, and B, so the reason I mentioned IPython is because Jupyter notebooks were formerly referred to as IPython notebooks. IPython is running inside them. Let's just look at one of these. Like, what does it look like to have a Jupyter notebook? Here's one, DC data processing. So it's a container. It mixes text, and then it's got some code, and that's not fake code. That's code that does something. In this case, it reads in this CSV file, and then more text, and then it has some code that outputs something that looks an awful lot like a spreadsheet. And the point here, we'll go into how to sort of use Jupyter, but the point here is it's a container. It's really good at doing things like reports or like actual notebooks. And if you can see, I think if we're reading what I'm doing here, I've got lots of notebooks. This is me reading in some data in a CSV. This is like, how much traffic did we get on this site? You look at a CSV, you're like, I don't know, there's a cell that's got a bold font, so maybe that's the total. You don't really know, right? In Jupyter, you can document things. And in fact, what I'm doing here, in addition to crunching some data, again, text, code, I'm instructing my team. So I have a team of analysts. I work at IBM, and I sort of dabble with data science. And I'm saying, hey, you guys, I want us to use these data science tools. So here I'm making some recommendations with documentation, outputting some results, finding some totals for monthly. I mean, obviously, Jupyter notebooks get used a ton for analytics, and that's because you may be pulling in a bunch of spreadsheets, or you may be pulling a live server off the web. You're calling databases in real time, or you're getting all the Twitter handles that did something and saying, just pull those in right now and let's crunch them into a notebook. So again, we're just sort of looking at notebooks here, but here is code output, more text, me explaining, oh, last month jump. Is this an interesting feature of the data? So it's the sort of thing you might do in Excel. And then finally, more crunching. This is one of the best things, that you can take the data and you can crunch the data and then you can plot it. So there's lots of plotting software inside Jupyter. That's one. And you notice when I open that one notebook, it keeps me open in my home directory. So it's got a sort of a sense of home. We can look at another one. Here's another one, also typical, also me sort of writing reports for people, pulling a lot of data in. I'm pulling in the plotting library, and I'm sort of setting up a big table of data. I'm showing that data. We've added some things to that data. Right? It's a container. It's got running code. I change the code. I change the data sources. I change the text. I rerun it. So it's kind of live. It's like a live spreadsheet, but it's got the best example of like, you can document what you're doing. You can plot things. It can be taught to run whenever you want it. It can pull in data sources that are live as opposed to sort of CSV, flat files. So I'm going to show you sort of how to get around in Jupyter. And to do that, I've got to get my Python act together because I'm only on Python 2. There's a newer version. But we're looking at notebooks, but I'm going to start a new one. So I just say, I want to do a new notebook. And then we're going to talk about how you would actually use Jupyter really briefly, and I'm going to go into those examples I talked about. So when I open up a new notebook, it says, it doesn't have a title. I can name it My Notebook. And once again, I really do use Jupyter just for sort of meeting minutes or just keeping track of things, writing little reports. The most important thing to realize here is, so this is a container, and the atomic unit of information in this container is a cell. You build a notebook by assembling cells together, cells of type code, cells of type text. Maybe the code outputs a graph, bar graph that you're going to hand to your boss. Like, here's all the documentation and all the code that I can run, and here is the plot that shows you the bar graph proves that we did better this month. So you can put it all in there. The most important thing about this is I've got this cell and I can type things, but the type of cell this is code. So it thinks we're going to get cranking on Python or something. And what you want to do, or what I like to do if I'm writing a Jupyter notebook is I want to sort of begin things right here, right? So here's a heading, and here's some text. That's one cell. And it says Markdown, so Markdown, for our purposes, means a text cell. Markdown, which we won't go into too much detail about, is also very dominant text formatting. It's a way to format text that makes it really quick to sort of generate lists and tables and headers, as I'll show you. This is a cell. I've edited it. It's on my own machine. And what I do is I run it, and it quickly outputs HTML. That's completely uninteresting HTML. I just had regular text. If I double-click in this cell, this is the first of my cells, and I start using the syntax of Markdown, right? And then there's another subheading here. So now these are conventions in Markdown. I'm editing text. It's extremely efficient to write in Markdown, so boom, I'm doing my meeting minutes in here. And if I rerun this, it's like, this is kind of nice. Like I could just like write a lot of stuff. I could do headers, I can do lists, I can do tables, I can do regular HTML. So that's the text, right? Notice that when I ran this, it goes into a cell below. And this is code as well. When I make a new code, a new cell, it always gives me a code thing. So you're going to start doing Python. And I want to apologize to you. Like I want to sort of stay away from code as much as possible. And so if you don't code, it's no big deal, but I'm going to get a little bit nerdy. We're going to sort of go into Python for a second, because after all, we're mixing code that's munging data and then a bunch of text and what else, plots and so forth. The traditional thing you do in a language is just to see if the lights are on. You run a hello world or a hello Java or whatever. So this is live code, and if I run it, it puts the output right there, right? This is Python. And you can just avert your eyes if you don't want me to talk about Python, but I want to sort of get into some of like you're a coder. A lot of people, their journey to learning Python, this famously useful language, begins now with Jupyter. Jupyter notebooks are so dominant that people have sort of replaced their editors and replaced this kind of, they just go into Jupyter and they just start living in Jupyter doing Python because it's interactive and you can see things. So if I go back in here, let's just say there's like, I'm going to make a little variable here. Oops. Right, and I run it again. So it knows, right? It's like, oh, I'm interpreting variables here. Some of those features of IPython that I noticed are here. Like if I can't remember what J is, gosh, I've got all these variables. I had like a J, I had an I was iterating through something. If you do this right here, you're sort of talking to IPython and it's saying, oh, I'd like to remind you what that is. Here's what your variable is. It's actually a string, and its value currently is this, and here's a little bit of general information about this variable. And that I won't go too far into, but for coders, you're like, this is like I'm sort of dealing with Python here in a sort of in a nice way. By the way, my goal is for this meeting, it's just minimally, if you come away from here thinking that it's non-invasive and could be useful and is not intimidating, that's it. There's so much to do and we're not going to go into any detail, but I just want you to feel like, oh, Jupyter, like I could install that on my system and try it out and it wouldn't be so harmful and maybe I'd take some meeting minutes. And maximally, if I'm successful, this could be like a gateway drug to maybe a broader investigation of data science. Like you would be like, I know Jupyter Notebooks, I'm going to go look at RStudio or some other things. But it's really just like Ian did it on his machine, and you go into a cell and you run it, and it could be text or only text, or I could put a couple of lines, or someone gave me some Python and it got shared there. So here are a couple cells. Note a couple of other things. I can also, I can delete cells, right? I can delete this Python cell. I can edit this one, and I'm always running it, right? You can run everything in the notebook. You have 20 cells. They're pulling in data. So there's a lot of documentation on sort of how to get around in here, and there are, of course, keyboard shortcuts. So some people are, just using their Jupyter notebooks, and they're never touching the mouse. They're just cranking, new cell, delete cell, this kind of stuff. You might get used to that. But this is the basic sort of interaction of working with cells in a container called a Jupyter notebook. So I want now to talk about the tasks that we all might be doing in spreadsheets. Your boss says, I've got these 2 email lists and I need you to find the segment of both of them. I want you to, we've got a bunch of people here, we've got a bunch of people here. So what would that look like? This is a picture, another aside, this presentation was built with a Jupyter notebook. There's a way to take a Jupyter notebook and output it so it looks like slides. So that's actually sort of live code, but I'm just showing it in a kind of a nice browser window. The point here is, again, we're in the code world, we're not in the Excel world, but you've got these lists. There's a basketball list, like your kid's basketball team and your kid's ballet team. And we've got a little function, and if we run this cell, it says, oh, this Carol is on both of these. And it might be like, who on both of these lists would like to receive a promotion about basketball shoes that, you know, do ballet point or something like that, right? What's the intersection of these two lists? That's all by way of saying, hey, I made a thing called segment, so I have this little tool called segment. It can find intersections of big sets of data. Now, this is like Excel stuff. A little bit more data, but you can see what I'm doing here is b-ball is like a giant list, and it's coming from an actual spreadsheet. So it just says, it's almost English, right? Read Excel, go get that basketball spreadsheet. Go get 50 spreadsheets. Or your boss says, you're not going to like this, but you've got 100 spreadsheets, and I'd like you to find every reference to, you know, Starsky and Hutch in there, and all of them, and then pull that into, and then whoever did it, then like send them an email, or figure out the average, right? You're working with lots of spreadsheets. So I did the same thing here, but now it's like, go get the b-ball list, go get the ballet list, they're much bigger, just do the same thing to them. So B's, a new variable, is this segment of b-ball and ballet. It's a lot more people, but it's kind of nice. Like, what if I had 20 spreadsheets? What if your boss says, please open and cut and paste? You're like, no, I'm gonna do some Jupyter notebook here. Where I'm going with this is that like, what's Jupyter better for? Well, you could do that in Excel. There's probably ways that I don't understand to do that. But now we're still in the same notebook, and this code, it's kind of pseudocode, but this says, you know that bees list? There's like 50 people. Like, in the notebook, build a little email automation and just find bees, maybe recalculate it every time that spreadsheet changes, and then actually send the email, right? Basketball point shoes on sale. Gets sent to bees, right? Send mail. It's sent from me. So this is some Python code again, but it's like, it's sent from me, it's going to this big list, and then just quit the mail server. So I've actually started a mail server in Jupyter. I crunched some data in Jupyter. It could be a lot of data. I segmented a market segment, and I did some email automation. So it's like, you know, now we're sort of moving beyond Excel. We're kind of getting into this more interesting world. This is sort of a teaser, but the world, if you do go into the world of programming and you're in Jupyter taking your meeting minutes or just crunching 2 spreadsheets, you're like, oh, I'm going to use API calls. I'm going to go talk to Twitter feeds and find out who's tweeting what. I'm going to crunch that data as well. Oh, I know, I have to be sensitive to time too. We have so little time here. So I got this really cool set of data. This is actually local real estate data, and that's maybe more, another set of activities to do is to, again, pull in a spreadsheet like housing prices. I got it from New Hanover County. And what we're doing here is saying, I'll show you this spreadsheet too, like that one. I think it's this spreadsheet, I just have it open. Oh, so here's basketball, and here's a big, you can't see it very well, but it's just like 10,000 rows. This is like every parcel that was sold in the last 10 years or something. Prices, square footage, a monstrous amount of data. So here in Jupyter, let's just pull it in, and then let's add a new bit of value. So PPSF, price per square foot. It's like, oh, I know, we can just figure out the price per square foot by getting the square footage, or by getting the value and dividing by the price per square foot. Now this, I'm not sure if this data is reliable data. There's like 80% of the job of a data scientist, it is said, is to actually just like clean other people's data before you can use it. You're just constantly refining the data. So who knows if these PPSF values are real, but it's real data. And so I said, add to our data this PPSF column, and then, by the way, start segmenting these. Like, big houses are ones that have larger than 2,200 square feet. Maybe that's not the right number, but tiny houses are less than 900. New houses. So I'm getting these segments, right? And I'm showing a little bit of the data. I'm in a Jupyter notebook, and the output is this sort of this table that looks very much like a spreadsheet. And where this goes is I'm working with, like, so now I've got these different segments, right? I've got big houses, tiny houses. I'm trying to find out the price per square foot. So if I think I might have to go to the other version of this, right? I'm using, let me go to my, right here. I want you guys to have a better look at this. So this is like the master copy of my presentation. And you can see it sort of says like slide. I built a slideshow out of it. But if we actually go to this data, so you can see it's the same data here. I got my big houses, I got my tiny houses, and I can plot it, right? So I just say, okay, like divide up that data, start finding the mean price per square foot, and then just calculate it, and the result is this little plot. Like, that's nice. Wow, old houses are a better price per square foot value than big new houses? I mean, this could be completely bogus information. Again, I didn't clean the data, but I'm just in this one container, right? And so this container mixes code that runs these, pulls spreadsheet data from all over the place, can do so as that data is updated, documents what I'm doing, and then for the boss or for whoever you're like, and here is the bar graph that shows this. So you can do it in Excel, but you can kind of surround it with live code that's actually processing the stuff on the fly. I think, yeah, we're sort of already at the bottom here. And I want to, the thing is, Amanda helped me put a message into the Slack channel. And there's only time just to sort of touch on this stuff at the very beginning. But I put some resources in here. And I said through her that if you want to continue talking about Jupyter Notebooks, or perhaps find there's data that you're using here at tekMountain that you want to, with me, put into a Jupyter Notebook or experiment in sort of crunching the data from, I would absolutely love to do that. And if this is the beginning of more of this kind of stuff, I would love that as well. So you could approach me individually about like, I didn't get when you said this, or we can have some questions right now if you want. I've left, again, the world of information about Jupyter is here. There's some notes. I put the original article here, Jupyter is the new Excel. And I think we'll bundle this up and send this as part of the thing. We'll have a video and everything. But I don't know if you all have any questions, but if you want to follow up with me in a little team, or you say like, Ian, I've got these 5 spreadsheets and I want, like, would you show me what you did with that stuff? It would be my delight to do that. I sort of like playing around with this stuff. Are there questions for you guys right now? Yes.
So can you run numbers and things on another server?
Oh, yeah.
So you could connect and then crunch it somewhere else?
Yeah, I was sort of like, I was interested, I was going to try to avoid data science and too much computation, but that's the gateway drug. So if you take minutes in a notepad, you can use Jupyter. If you use spreadsheets, like the focus here is like, well, we're all using spreadsheets for our fantasy football. This could be a better way to do that, just like it's just a spreadsheet. But the point I'm making with that sort of poor man's email automation is you're just in the world of Python. So all libraries, sort of parsing libraries, API access, it's all there. So in other words, let's say you want to do some number crunching on these 10 spreadsheets. One of them's on a server, another one is not a spreadsheet, it's a database and you're just talking to the database. Or you're using an API to talk to some real, like stream data. All that's just like also one-liners. The stream data from Twitter about the number of times that, you know, this has been mentioned is just coming in live. So you run this and it's just cranking data. I wanted to sort of focus on spreadsheets because we're all using them. We've all gotten sort of familiar with Excel, so it seems like it's easy, but it's like a bananas thing to use. I mean, it's not easy to use. There's like, if someone gives you their spreadsheet, like it has any complexity at all, it's like, there's a macro that I don't know where it is, but it's doing something, and then all this data is on this sheet. Like, how can I help you with this? I don't even know what this is. And one of the virtues of Jupyter, aside from the fact that you're gateway drugging into like the world of all computation, is that it's sort of legible. Like Python's legible, I think it's legible, and a notebook is set up to be, again, this perfect container. 360-degree surround of your data with neat documentation, visualizations, all these libraries that just make it like, here's the report boss. And it's fetching data off the server. You know, whenever you run it, it goes and fetches new data. It's the sort of thing it's meant for.
Coming from like someone like a first grade education, computer science, well, it's hard for me to grasp. When you compare something to Excel, I want to see cells and columns. I didn't see one.
Yeah, let me.
That's why I was like,
I know. I was sort of like, I maybe sort of winged by those. Well, let's go into here. What I want to show is like, so here's sort of the master copy. But this right here, so I got my segments. There's a bunch of data, and I think you saw the housing prices is just a bunch of data. I added to the data, and this is the output. This is sort of typical in Jupyter. The head just means like, okay.
So to start, you have to start with an Excel spreadsheet before you get into
Not a bit. This is only, we're all using Excel. There's a better way. So I'm only going to talk about Excel. But you can easily, of course, define the data. You can fetch data remotely. You can define data. Remember that in my email example, like if you're going this way or for some reason, so there's no spreadsheet here. This is like, I've got a b-ball list and someone gave it to me in email. I'm just going to paste it in there. And this is a really simplistic example, but the code sections, right, you can do text or you can do code. The code section can define data, it can gather data, and one of the ways it does, that Jupyter does it, is by saying, I know how to read spreadsheets. And if you've got 50, I'll read those. But I also know how to go get it out of a database. Or I'm just going to do, like I work continually with Jupyter notebooks, and I just have the data in the notebook. It's like, I don't know, housing prices are just like, they just live, the data can live in Jupyter. It doesn't have to come from Excel. It's only that like our hands are soaking in Excel use, and I want to sort of say like, there's a better way to do it. You could just like use this.
So you just want a real simple spreadsheet. It's a kid, parent, right?
Yes. So kid, parent, email. As I think you saw, like when I bring this in, this says like, this is specific, right? It says, B-ball. Go read this Excel file. You saw me, it sort of rushed by, but there's a Excel file called B-ball. Open that file, and then get me the column called email. And turn that into this, it's actually like it's a data structure. It's like a data frame. But B-ball is just this thing now. So all the data is in B-ball. I could define it, or I can just read it in, right? Yes. Yeah, let's see here. So I've got, this is live, right? Well, here's a simple example. This is a very simplistic example, but this is live code. How do I know that? So I'm going to run this code, and recall that what this does is I have this function called segment. And it takes two lists, and it says, what's common to those? There's like some math in here. And Carol is the only one who's common here. But if I put, if I put Barry up here, I got to put him in quotes here. If I add Barry and I run this, I rerun it, Barry, and so this is live, and it's routine for people. If you don't mind having a Jupyter notebook that's just got like all this data, these lists could be 10,000 people long. And there's sort of nice ways, like right now, because I'm in an interactive interpreter, if I do this, right, it's kind of nicely formatted, right? It's not just this big schmear. I could have a list that's kind of legible that has all my data. And as I add things that are common to both, it just keeps cranking through there. It goes, oh, now you've got 3 people? Oh, you just added 10,000 names? Well, there's still only 3 common. So this is sort of I'm doing really simplistic examples, but I have a function segment. Its business is to determine the intersection of 2 lists. The lists are here. So all of the data for this example are here. And I wanted to like go through here so you didn't glaze over about programming, but this is like an interesting part of it. If you're just working with spreadsheets, you just read it in as I did in that other example. But if you're just building data, you can just let it live. You can just give it a whirl, and I encourage you to do that. So was I successful? I'm minimal success is you're not intimidated, you might give it a whirl. Okay, good. And I want to thank Mary, too, by the way, who helped me. I'm like working to